Hello, and welcome to Stat 2050 at the University of Wyoming. Online, having a great time. Okay, so today is the first video. Today is the day, right? We're actually going to be learning stuff. Or maybe just reviewing stuff. Because in this case, we're not going to be doing all too much math, just a little bit, just a super tiny bit. We're actually just going to be talking about concepts in statistics, especially statistics in the news. Very prevalent, right? Especially in this day and age. But before we get into it and talking about all that, one thing that I like to do is share the music that I'm listening to this week. You can kind of think of it as the album of the week, which in this case is Monterey by the Milk Carton Kids. If you're looking for like a nice relaxing time, this is it, right? This is a great album. It's perfect to study to, great to just relax to. I've seen them like 5 times. They're great live, right? So if you get into them, really fun. So check it out. All of these songs are just super great. It's going to be the best 37 minutes and 29 seconds of music, I think. Anyway, let's get into it. So the way that this class will kind of be structured, I'll have these food for thought ideas. And what I want you to do, or at least encourage you to do, is pause the video and read it and just sort of maybe answer the questions on your own. There are no right answers. There are no wrong answers. It's totally opinion based. I will briefly give you my opinion. I'll try to keep it as brief as possible so this video is not an hour long. And it's okay, though, if our opinions are different. That's like totally fine. It might be that I catch something that you didn't, or you catch something that I didn't, right? And it's totally fine. If you're confused, or if you are totally lost, send me an email and we can actually like chat about it. But I encourage you to kind of think on your own for just a brief moment, and then I'll talk about it. So pause the video, check it out, and then unpause it when you're ready. Okay, so I imagine that you paused the video, read it. So let me read this real quick, and then I'll give you my thoughts. So a recent newspaper article concluded that if you smoke weed, you're going to be, you'll have lower grades in college. Okay, so we have everyone's favorite stoners right here, Cheech and Chong, Up in Smoke, just a great movie. But they might disagree with this, right? I think I might disagree with this. Because we don't have enough information here. When they did this study, well, first off, not when, but who did this study? This just says a recent newspaper article concluded. Where did they get that information from? Is it from the local university, or is it from, something that they did on their own? If they did it on their own, then you could imagine that if you're Cheech or Chong, and then you get approached by somebody and they say, hey, do you want to do a survey for the newspaper? You have to smoke weed, or you have to be someone who smokes weed. Probably not going to be totally receptive to answering, right? Okay. Also, we don't know if they have like a control group, if they compared people who do not smoke weed to people who do. We don't know how much. They say at least 3 times a week here, but at least 3 times a week is, that's the sort of the floor there. We all know people. We all know people that smoke way more than that, right? And we don't know sort of the range of people sampled in this. We just don't know. So is there a more reasonable conclusion if we had more info? If we had more info, then it would be much easier, I think, to make a conclusion here. Okay. Same kind of idea, right? So suppose you were to learn that a large state university graduated more millionaires than, or people who become millionaires, than a small liberal arts college in the same state. Is that a fair comparison? Well, if you look here, well, this is actually where I went to college, College of Charleston. It's got 10,000 people. It's got 10,000 people, which is what I've got sort of written up here. And then we've got this place over here. This is the University of South Carolina. Absolutely garbage. Don't ever go. It's in Columbia, South Carolina. Absolutely just a trash can the whole time. But they have about 60,000 people, I think, that go to school there. Much, much more, at least, than the old College of Charleston here. Okay? So this university here kind of makes sense that they're going to produce just more of everything because they have more people, right? So you can kind of see what I'm hinting at already up here, but I've got 100. Let's just say that 100 of the 10,000 people who graduated from the College of Charleston became millionaires. But then we've got more people over here who became millionaires, 101, even though that's a very small difference, but there are more, right? There are absolutely more. 101 out of 60,000 became millionaires. So it sort of doesn't make sense, right? If we were to work out the math here, this is 1%. 1% of the graduating class became millionaires, whereas in this case, even though there were more people who were to become millionaires, this is only 0.1% of the graduating class, or of the whole, student population there. Is that fair? No, it's not. Of course it's not, right? Relatively, when we put things in percentages, we're calling that putting things into relative terms. Relatively, we have more people who are millionaires at the smaller school than there are at the larger school, even though there are absolutely more millionaires than there are at the smaller school, right? So that's just manipulating data. That's the same number, right? But two different stories. Interesting, right? Food for thought. Last one in this sort of segment. A magazine sent out a survey to all of its subscribers, and of the 65,000 people who replied, it was a survey on violence on TV. It said 97% of those 65,000 people were very concerned about violence on TV. Okay. So here's my first thought on this. I don't subscribe to this magazine, and I have my own thoughts on violence in TV, right? You probably don't subscribe, and probably all your friends don't either. And I assume that, we're all relatively young, under 40, we'll say. People who subscribe to this magazine, right, you can kind of imagine, maybe, are relatively old compared to, the rest of the nation, right? So when we look at this question here, can you conclude that 97% of U.S. citizens, right? So we have 97% of this large number, and then 97% of, I guess, 320 million, right, in the U.S. are concerned about violence in TV. We probably would say no, probably not. But why? Well, because this survey that got sent out is biased toward the demographics of the people who subscribe to that magazine. And it may be that, and we can kind of maybe assume that the demographics of that magazine are going to be kind of old, right? At least older than the, mean age of the U.S. population. This sample here is not representative of the whole U.S. It's going to be more representative to maybe, every magazine subscriber or all the old people in the U.S., right? It's not going to be representative. Not representative. Okay. So when we're working in statistics, typically we have three goals, right? Or three things that sort of beef up our research study. The first one, and I think the most important, and this is sort of listed in importance too, in decreasing order. The most important is you want to get a representative sample. You want to get a representative sample. So you want to get something where, you can never really ever survey the whole population. Either it's too expensive or the population is always kind of moving. People, not to get morbid, but people die, all the time, and then people are born too, right, all the time, probably at about the same rate, right? So we don't really know. Actually, I guess not. I guess there are more older people than there are younger. So anyway, the population is always kind of fluid. It's always moving, right? We never have a good idea of what the whole population absolutely looks like. So that's why we get samples. But when we get samples, we want to get a representative sample of the population, even though the population might not be, the easiest to kind of define. And to do that, oftentimes getting a large enough sample is the key to getting a representative sample. However, we saw the opposite of that, where we got a decently large sample in this example. The 65,000 people, that's a lot of people. But it's not representative, right? Okay, so always get a representative sample and then make sure that it's large enough. We'll talk about specific numbers in a future lecture, not now, but generally, the larger the better. And then you want to decide whether the study is going to be observational, where you go out into the field and just look and observe and then record your findings, or a randomized experiment where you are an actual researcher working in a lab or something like that, where you go get people, you sample people, and then you do something to that group, right? You do some experiment, okay? And that's, probably the least important here, whereas these two right here are the bread and butter of good statistics. Okay. And also we'll talk more about this in future lectures too, because it's a whole thing on its own. So this whole idea, all these food for thought questions, have kind of revolved around the idea of, and I'm sure you know, bias. It's all biased, right? All of those samples, all of those studies that we saw earlier were biased in some kind of way, right? Okay. And that just means that it's just not representative, right? So I have this sort of picture over here of a whole population. So let me do this. So we've got this whole population. And within the population, we have a bunch of different opinions. And I have, let me get a different color here. I have denoted the different colored, or the different opinions by colors, okay? So we go out and we want to survey. We cannot survey the whole population. We don't have enough money to do it. So we have to get a sample. But we want to get a representative sample. And we want to get a large enough sample. And so we could say that, each person here represents 10,000 people, we'll say, or 100 people. It doesn't really matter. But we want to get something large enough. If we were to just sample, one person, that's 10,000 people or 100 or whatever of just that one opinion, right? That's not going to be very representative, and it's also maybe not large enough either. Okay, so let's say that we need to get at least, maybe one more. Well, if we were to sample these two opinions right here, well, we would get kind of a tie, right? We've got 100 people of both the purple and the blue opinion, and we wouldn't really ever come to a conclusion. Also, we're leaving out the gray opinion here too, which is not good, right? Okay, so we need to get more people in it, says our boss. Okay, so let's get these people. Uh-oh. Well, now it's going to be biased toward the blue opinion here. Even though we've got the purple opinion in there too, we're leaving out the gray opinion, but we're also not getting a totally representative sample again, right? So ideally, we want to do something like this, where we get a little bit of everything, right? We get the purple opinion, get the blue, and get the gray opinion, right? And in that case, we've got a very good representative sample that is large enough. And then after that, we decide whether we are doing an observational or experimental study. Okay, another thing. An improper use of statistics is when we don't have a control, right? And a control is just, if we go back to the marijuana example, a control would be, in that example, people who do not smoke marijuana. And then you compare their GPA or their grades or whatever to people who do smoke marijuana. But we didn't really get that information in that question, right? We only got the people who smoke marijuana, okay? Another thing is the units used here, per capita, per square mile, per city block, whatever, right? In this example here, we didn't get any units. We just kind of got, we got people, right? But that's not totally representative, right? Because we know that by percentage, by relativity, something a little bit less biased, then we say that actually it's this place that has more than this place. Okay, so it's all about the units that you use. It's all about using a control, right? Very important here. And then the last thing, if you're doing an observational study, let me get this out of the way too. If you're doing an observational study, where you're just going out and observing, your sample, the world, it might be, a city block. It might be, like a group of people. It could be like a church. It could be in Wyoming or Montana. It could be like a Native American reservation. That could be your, observation group. Anything that you get from that, though, any result, any conclusion, is casual, right? You can't say with like really good certainty that what you saw is true for all the other groups that you're looking at or wanting to apply this to. Everything you get is totally casual. When you have an experimental study, things are a little bit more concrete as far as the conclusions go. Still not totally concrete, but certainly more than the observational study. The observational studies, their biggest issue, their biggest kind of drawback, is that there's a lot going on that you're not recording, right? There's a lot of variability that might be seen or unseen that you just can't do anything about. Okay. Last, I think this is the second to last one. Okay. So I just sort of the long and short here is that you're trying to quit smoking, and you read something about people who used a nicotine patch. It was twice as effective as getting people to quit. Okay. What questions do you have? I have a lot, right? For me, maybe, just totally hypothetical, maybe I'm more of a casual, like social smoker, right? At the bar or out at parties or whatever. Maybe that's when I go out and smoke, and that's what I want to stop doing, right? It might be that in this study here, they used a group of people that rip like 3 packs of cigarettes every day. That's a totally different level of addiction than what I have, right? It could also be the opposite. I could be somebody who smokes 3 packs of cigarettes a day, and the people in this study were people who only smoked socially. Okay, so it might not be totally applicable. The sample here might not be representative of the group that I am in, right? Okay, just food for thought, right? Plenty of opinions there. Oops. Okay, I think this is the last one. Yeah. Okay, so a door-to-door survey. Awful, right? On opinions on various political issues. Okay, so that's the first big thing here, right? I don't know about you, but if somebody comes to my door and wants to talk about politics, I'm gonna shut it. I'm gonna shut the door and lock it, and then lock myself in my room and not talk to these people, because I don't want to. The only people that will respond, or people who may respond, right, are gonna be sort of the political zealots, the people who really care. And always want to talk about politics, right? Oh, Lord, So that's going to be, more often than not, those will be the people that answer those surveys. Okay, so that's the first sort of issue there. But the real question is, do you think it matters who conducts the interviews? Wow. Okay, so that's a heavy question. That's very heavy, and there's a lot to be said there. I'll keep it brief in what I think, and I'm sure that you have opinions too. But if you've got somebody coming over and they are representing the opposite political party to you, that's probably going to greatly skew the answers, right? There might be a little bit more sort of aggravation, maybe, a little bit more hostility towards the answers or towards the questions being asked, right? I think it does matter, especially if you take everything out and if they are just representing some other political party. That's going to be a big issue, right? You're going to get very biased answers, I think, right? And there's a bunch of other things that go into that as well. Okay, so the educated consumer of data. Whoa, that's how you say it. Data, not data. Just kidding. You can say it however you want. Let me rewrite that too. Oh, jeez. Data. Okay, data is a plural word referring to pieces of information, right? So it can be people, it can be animals, it can be chemicals, it can be whatever you're studying, right? The small little components that tell the story, right? Oftentimes, when you're reading stuff in the news, online, hearing it on TV or whatever, it's summarized for you. Okay, a person has typically summarized the data. What do we mean by that? Well, we have the sort of cardinal directions of statistics, the mean, the median, and the mode. These are the three most common ways to summarize data. In most cases, right, these are all known as, average. All of these things here get bundled up into this term, which is not cool, right? We'll talk more about the math behind the mean, the median, and the mode, right? But for the most part, or at least in short, the mean is quote-unquote the expected value. So let me come down here. Okay, a little hard to read. Again, don't worry about this for now because we will actually do more with this later. But the mean is the technical term for that is the expected value. So thinking about it in sort of practical terms, if I were to take a big group of people, look at their heights, and get the average, we'll say just for males is 5'10". If I were to pick some random person out of there, point at them and say, I expect you to be about 5'10", right? Would probably be more or less in the ballpark, right? And that's kind of what the mean does. The median, on the other hand, is if you were to order all of the heights from smallest to largest and pick the middle one. And the middle one is the one saying, okay, everything below this value is 50% of the data. So 50% of the data is below the median. And then 50% of the data is above the median, right? So there's one value. Once you line up all of the numbers, heights in this case, from smallest to largest. And then the mode is the most frequently occurring, right? Which, when we get into it, if we have a sample size that's large enough and kind of represents a normal distribution, again, don't get hung up on that for now. But eventually, all of these values will approach about the same number. But it is a shame that even though all of these mean something, and sometimes they are about the same value, they're calculated differently. They mean something just slightly different. They all get put into this. The average American. What does that even mean, Is it the mean? Is it the median? Or is it the mode? Well, we don't know. We need more information, right? Very, very important that you keep that in mind. Okay, the origin of news stories. This is big, right? This is where, here, these first four, this is the big four, right? This is where you should be, at least, it's a little bit more trustworthy than something you see, on Facebook or whatever. If they are sourced and they, kind of fall into any of these four categories, booyah, you're set. But as Kate McKinnon said from SNL, trying to be like Laura Ingraham, in news stories, sorry, I'm just thinking about this skit. It's so funny. A lot of news stories are fuel facts, right? Where fuel facts are not technically facts, but they feel true, right? And oftentimes you'll see fuel facts in real life that are kind of based in these four, but then you've got some opinion that goes behind it, right? You're sort of tweaking it to represent your own narrative. Okay, so not great, but that is the origin of news, right? A lot of the times, at least in this day and age, very rarely do we ever just get these four, and then that's that. There's always somebody saying, what they feel about it, which is not great, All right, here we go. So I got to get my notes up for this one. So give me 1 second. Okay. So, the seven critical components of research, okay, or of statistics. And especially when you're looking at statistics through the lens of a skeptic, right? Which I hope that you all are, because that's how you learn, especially in real life. Okay. So number one, the blank of the research and funding. Well, we want to see what the source, where it's all coming from, right? Where's the money coming from? Where is the research coming from, right? We all know that money plays a big part in research, right? And if the money is coming from an unbiased source, so like the NIH, the National Institute of Health, right? They're fairly unbiased. They really only care about disease and disease tracking and research pertaining to health and wellness, right? They'll fund pretty much anything, pretty much anything in that regard. But you also have funding sources that are biased, and they want to kind of improve their narrative, right? Or further their narrative, which leads to kind of biased research, which is a shame, right? But it is, reality. And then number two, the researchers who had contact with the participant. Let me do this. If I draw with a smaller, we're all learning here. The researchers who had contact with the participants, right? Kind of like that door-to-door survey, right? We might get some biased answers if the researcher who had contact with the participants leaned one way or the other as far as politics go, and was like vocal about it. Okay. And then the the individuals or the things or the participants studied and how they were selected, right? Not great. That's okay. The individuals studied, right? So you want to make sure that you get when you're selecting your sample, you want to make sure that you get a representative sample, right? Very important. Number four, the exact nature of the measurements, right? So when we were looking at the college, those two colleges, we saw that, the bigger school had more millionaires, but relatively the smaller school had more, right? As far as the relative looking at the whole picture, right? Rather than just the kind of granular looking person to person, okay? And then the setting in which the measurements were taken, right? If you were to go into a big, scary lab with white walls and no mirrors and no windows, that's you're gonna have some bias there. You're gonna be kind of spooking the people, I think. Whereas if you were to do it in their own house, you might get some different answers. Just stuff along those lines. Okay, and then you want to see the differences in the groups being compared, in addition to the factor of interest. We'll talk more about this. In future lectures, but just sort of keeping that idea in mind. You're really looking at the differences between two groups or three groups or however many, and you want to make sure that you're keeping, your research goal in mind. Okay. And then lastly, the extent or size of any claimed effects or differences. And, we'll actually talk about this more, too, because there's a big deal there when we get into hypothesis testing, quote unquote. It sounds hard and sounds scary. It's really not that big of a deal. But oftentimes, we can get, something that shows up as statistically significantly different, but is not really that big of a deal, right? It is not actually, significant. In statistics, and again, more on this in the future, but in statistics, we have this idea of significance. Statistical significance is much, much, much different than like English significance, or at least in the way that we use it in English. But again, keep that in mind, but we're not going to talk about that for just a little bit. Okay, looks like that's it. So, thank you, and I hope if you have any questions that you can email me, talk about it. And then I will see you next time.